Welcome to the External Tools breakout session. My name is Phil Durbin. I'm a software developer, one of the core developers for Dataverse. And I'd like to introduce, I'd like Caitlin to introduce herself, please.
Hi, everyone. I'm Caitlin Newson. I'm the Digital Projects Librarian with Scholars Portal, where we host Dataverse for 55 institutions across Canada. Do you want to go to the next slide, Phil?
Sure, here we go.
Great, thanks. Okay, so we've got a pretty full agenda for today. So we're just gonna kind of dive into it. I first wanted to remind everyone that there's a code of conduct in effect for the Dataverse community meeting, which I think you should have all received in your email inbox. In terms of our agenda for today, Phil's going to get us started with some background on external tools. Then we're going to have some 5-minute lightning talks from 9 speakers about different external tools and developments they've added on to Dataverse. And then we're going to jump into questions and discussion. So as people are speaking, we'd ask that you put questions in the chat, and then we'll save those all for the end so that we can make sure that everyone has enough time to get through their presentations. And so in terms of Zoom, just a few reminders: make sure that you're staying muted unless you're speaking or going to ask a question. There's a functionality to raise your hand. You should see it over on the right side of your screen underneath the list of participants. And you can do that if you want to ask a question. When you're speaking, you can turn your video on so that we can see your lovely faces and engage and have some of that face-to-face that sometimes we miss out on these audio-only calls. And there's a chat function. Again, that's in the lower right corner of the screen. If you don't see it, you can open it at the bottom of the Zoom window. And this session will also be recorded, and the recording will be made publicly available. And I will also share the notes again in the chat for anybody who has joined recently. So we have this shared notes document where we hope everybody can pitch in, and I've kind of started an outline of today's session there. So I think that's everything for me. You can go ahead, Phil.
Great, thanks. So before we dive into the 9 speakers who are going to be explaining all the cool stuff they've built, I want to give you a little bit of background on what we're even talking about with regard to external tools. So Dataverse has certain functionality, but the way I think of external tools is that it's a way to provide additional functionality to Dataverse. So let's dive in. The screenshot you see on the left is a screenshot of the new interface that's coming with Dataverse 5. And you'll see that we've reorganized things a little bit. You may be used to seeing an Explore button, for example. And now what we have is Access File. And then we've broken up that drop down into 2 sections: Download options and Explore options. So down in the Explore options, that's really what we're talking about today. I put just a couple of fake examples in the screenshot: Awesome Tool and Fabulous File Tool. But the idea is that this list can shrink or grow depending on how many tools you've added to your installation of Dataverse. And on the right, what we're seeing is just a normal URL. And in some ways, I think of an external tool as a glorified hyperlink, at least from the Dataverse perspective, because what we're really trying to do is construct that URL. And this is a very simple example. We just have a tool.com and then question mark, file ID equals 42. That's called a query parameter. And that's not a Dataverse thing. That's just the way the internet works, the web works. But that's a lot about what external tools are about when it comes down to it. So again, we're constructing hyperlinks inside Dataverse to point to your tools. Thank you again for building all of these tools. Here we see a couple of query parameters. Instead of just file ID, we also have added site URL. And from the Dataverse perspective, we call these reserved words within the external tool framework. So we launched with 3 reserved words that you can use as a creator of a tool, that you can request the database ID of the file, call it the file ID. And then you can also say, well, my tool needs to know the site URL, the URL of the Dataverse installation. So that's what that is. In this example below, we see demo.dataverse.org. And then lastly, an API token, which is used to authenticate. Okay, so we got the external tool framework rolling in Dataverse 4.8.6. We only had 2 tools, but they were awesome. 2 Ravens and Data Explorer. And we had some limitations back then. We were just getting started. We had tabular files only. And then this was sort of read only and explore only. That's all you could do with the data. And all these slides, you'll see that I'm highlighting in red basically the changes from the previous slide. And now we're talking about Dataverse 4.13. Jim Myers came along. He's going to be one of our speakers later. And said, well, what if we had file previewers? And these are fantastic. They allow you to look at the contents of a PDF, for example, or listen to an audio file in Dataverse. But to do that, we had to get away from the idea of tabular file only. So he added content type as a config option for the tools. That means that you can, again, specify this tool is for images or audio or whatever MIME type, content type. He also added dataset ID and dataset version back then. Dataverse 4.16 was a big deal because we switched from having only exploration tools to having what we call configure tools. That's what we call the type of the tool. So now tools can write back to Dataverse. And for the use case here, it was Scholars Portal. Victoria Lukic created, and Caitlin created this data curation tool. And I think we'll hear about this soon from Caitlin. But the thing I wanted to emphasize here is that these external tools drive innovation within Dataverse, because they had a vision for a tool where you could write variable level metadata back to Dataverse. But in order to do that, they needed the APIs for their tool to work. So along the way, Victoria also created the API endpoints inside the core Dataverse code to make that possible. On to Dataverse 4.17, another exciting innovation. Here we have a new scope variable where all the previous tools were all file level tools. But we heard from folks at Wholetail, and we'll hear from Casper later about this tool, that yes, it's interesting to explore a single file, but from our perspective as a reproducibility platform, we want all the files. We want the code, we want the data, we want everything. So we said, okay, fine, we'll make tools at the dataset level, no problem. And then along the way, added various reserved words at this point also. So PID is persistent identifier, so it means like the DOI. So you say, well, my tool doesn't really want the database ID of the data set. We want the DOI of the data set. So we say, sure, no problem, we'll send you the DOI. Then locale code is important because it allows the tools to be translated. Dataverse 4.18. This is again back to the previewers. So people are like, these previewers are great. Now we can like preview the text file before we download it, or preview a spreadsheet. Actually, it was Slav's group that added the spreadsheet functionality previewer. But you had to open the previewer in a different window. And what we decided is that it'd be much better to have a concept of being able to just see that file, that preview right in Dataverse itself. And so we did some work on the front end to have a preview tab, and then the tool can specify whether or not it has something that it can preview in that tab. So that was a nice innovation. And then here we're starting to just look into the future a little bit, where there's already been one pull request merged in Dataverse 5.0 about tool name, and that has to do with translating the tool, because tools can have descriptions, and we want that to be available in different languages. And then I have a few more bullets here. Allow path to be configured, not just query parameters. I'll get to that in a second. And then just some thoughts like, do we want tools at the Dataverse level? Do we want tools at the installation level? At the end of the session, we're going to be asking you to give us ideas and have a nice discussion about external tools. But I have one last slide here just to explain what I mean about the path, where again, in our external tools framework, we're all about query parameters. We'll send you the file, DOI, site URL, all these things. But we've done cool integrations with systems like Binder, and yet there's no external tool. So in this case, it's sort of on us, Dataverse, to make our framework more flexible so that we can construct different URLs. And so here in this example, you'll see that the DOI is actually right in what's called the path of the URL, which is before the query parameters begin. So just an example of how we could innovate in the future and continue evolving the tool, the framework for the external tools. Okay, and with that, I believe I'm going to turn it over back to Caitlin, because we're going to get to the meat of this session, which is our presentations from our guests. Thank you.
Thanks, Phil. I just want to stop sharing your screen and then I can share mine.
Awesome.
Let's see here. All right, is that showing up for everyone? I will take silence as a yes. Okay,
so I'm not seeing anything. Are other people seeing things?
No, I'm not either. It says, oh,
okay,
here it comes.
There it is. Okay, great.
Oh, it is working?
All set.
Yes.
Okay, great. Okay, so I'm going to talk a little bit about the Dataverse data curation tool. And Phil, let me know if I'm running over time at any point, but I think I'll be okay.
Yeah, 5 minutes. So
I included a quick link to my slides as well, and I've put those in the notes as well. So to give you some background on the data curation tool, it's an external web application that connects to Dataverse and allows for the creation and editing of metadata at the variable level using DDI. And the aim of this tool is to promote the adoption of standards and best practices, and to improve the description of the data. So some common use cases for this might be when users are uploading survey data. They want to add more information about things like, oh, I asked this specific question, or have some notes about specific variables, and add that back into Dataverse. So the tool works with any tabular files, CSVs, SPSS, save, etc. It was built originally with Angular 7. We recently upgraded it to Angular 9. It uses the Angular material theme for the front end and, of course, Dataverse's APIs. We have it available in both English and French because we are a bilingual service provider. So that's key for everything that we offer at Scholars Portal. And I've also included a link here to the GitHub repository. So some of the main features are that you can view summary statistics for variables. You can add different labels, groups of variables, or weights. You can create and edit variable level metadata, as I indicated earlier. This DDI XML can also be saved back to Dataverse and can then be exported by users. And there's also the DDI codebook, which I think Danny had shown earlier in one of the early presentations. And that is available for the entire data set. And that will bring in anything that's been added through the data curation tool. So this is just some screenshots of how you integrate or work with the data curation tool. So there's this configure button, as Phil mentioned earlier. You would click that and you would open the data curation tool for a tabular file. So then once you open the tool, this is the kind of interface that you would see. On the left, we see variable groups. In the center, we see kind of our list of all of our variables, options to view and edit individual variables. And then up in the corner are options to download the XML and save the file back to Dataverse. So when you open up that edit interface, this is the kind of form that you would see, and you could add in that extra information about interview questions, notes, and that kind of thing. If you click the view button, you will see some kind of basic charts and tables about the data and some summary statistics. So this is an example of what that code book looks like. So once I've made those edits back and saved them into Dataverse, publish my data set, then I will see all of those changes in this code book that you can open up through the dataset page. So we launched this in production in October of 2019. I've just included some links to some more information, a blog post that we did, as well as a link to a webinar that I know some of you had attended. And we also have some documentation in GitHub for the tool. So I just wanted to kind of, on a side note, for those that are familiar with the Data Explorer tool, which we also developed, we are working at Scholars Portal to upgrade the Data Explorer to have a more similar user interface to the data curation tool. So the Data Explorer is, a little bit older now and in need of some UI updates. So we're excited to be enhancing that tool as well. And that is everything for me. So if you want to get in touch with us, you can contact us at dataverse@scholarsportal.info. I will stop sharing.
Great, and you were under time. Perfect.
Excellent. Okay, let me just bring up my notes here. So Jim, I believe you are up next. So Jim Myers is a contractor working with GDCC and QDR and at times for TDL, many, many acronyms. He has worked on a broad range of scientific cyber infrastructure projects in the last 25 years. He's going to talk to us about previewers today. Yes, questions will be after the presentations. So take it away, Jim.
Yep. Okay. I was asking you if you could see the screen with the mute on. So is it up?
Yep, looks good.
Looking good.
Okay. So I have two quick slides on kind of the little bit of more details on the previewers and how to install them, and then a slide on how to make new ones. And just with all the logos up here, just point out that the previewer started with QDR, but they've since got a life of their own, and Phil has put them into preview mode, and we have spreadsheet previewers from other groups, and just recently that we're going to push out live internationalization from Encore. Right, we've got P Durbin up there and Encore, right? Their GitHub names are the ones that I know people by. But internationalization was put in, and then actually Caitlin added the French translation after the Spanish came in. So data previewers, I think everybody probably knows by now what they are. The point here is again that they've gone from you can pop them up as an external page, but now they're part of the data page as well. And they really can be anything. And the trick here, again, they look cool, but as I said in the EU Dataverse meeting, they're sort of a nice cheap trick for programmers, because a lot of what we're doing is, there are already image viewers and video players and audio players and things baked into the web. There are libraries for PDF. And really what we're doing is the kind of thing that Phil talked about, of being able to get the parameters coming from Dataverse in the right places so those tools work. So a lot of what you saw in the initial burst of things is just we're wiring things together, not having to build anything. And I think there are still other formats out there that, if you've seen a 3D viewer somewhere, if you've seen a viewer for a molecule, if you've seen a viewer for a map, any of those things that you can hand it the right data, those are sort of low-hanging fruit for doing more stuff. And I'll talk more about that in a minute. But again, it's sort of a nice trick, good for users, but also easy way to jump into development. To use existing previewers, again, they've moved to the GDCC repository at GitHub, and there's sort of two ways to use them. One is that these are actually hosted live. The ones that we've got right now are just HTML and JavaScript. So we basically use GitHub to host those things, and the user's browser pulls the HTML and JavaScript directly from GitHub, and all you have to do as an administrator in Dataverse is register that tool and tell it it's hosted over there. when the user clicks the button, construct the URL that Phil showed you and send it to that tool over there. In addition to that, if you do that, then basically as we update the previewers, your site gets those updates. And that's what internationalization, we've given people a warning that next Tuesday we're going to flip the button and make that come out. You can also download them and host them locally, so you can have your own copy. And again, you can pick which ones are turned on and turned off. And a little note there that if you're using S3 downloads, direct downloads, you need to do some core settings so that basically so that S3 content can get pulled into a page that's coming from some other site. Okay, and so the new things here that those have kind of existed, and I think we've talked about them even at the last meeting and previous meetings. I've also tried to give some description of how to build them. The new thing there is basically a new wiki page where I went into a much more in-depth discussion of how you do that. And I found some 3D, after somebody asked about 3D objects, I went and found a 3D viewer. I have no idea what subgenre of format it actually handles, but I just sort of went through the mechanics and all the way down into things like the particular 3D previewer I found actually can store the rotation of the object, right? Which view do you want to see, since the 3D object, if I get my hand in the screen here, where I go, right? The 3D object is really 3D, but do you want to see it this way or this way when the person comes in? If we only had more metadata, you could actually specify that. And so, you know, there are things that you, with these more complex viewers, you might want to think about how you want to handle that. Should you have more metadata on the data set that then we can pull across and figure out what the right view is? All those sorts of things are possible. But again, if you're into that, please go dig in there. That said, this is really all you have to do sitting here on the page. And you know, again, you don't necessarily need to read a lot of code, but the point is that just like Phil was saying, that Dataverse constructs a URL and hands you parameters. All you're doing when you do the rest of this work is say, put on the page, you know, for example, on this line here, put on the page in the preview element, put an audio player, and tell it that the URL is the one that points to the file in Dataverse. And literally, this is the entire audio previewer. The fact that it knows how to play audio, that was already in your browser. All we've done is this. And the other variant of these things, which in the little toolkit we put together, you say true instead of false when you line this up. If your tool doesn't take the URL, but actually takes the data, like a text previewer where you want to get the actual words and stuff those into HTML, you can get the data instead. And all it's doing is downloading it from Dataverse and handing it to you instead of making the library underneath have to deal with that. So these things can be really, really simple. You can do everything yourself. You can write in Java or Python or your favorite web language and create one top to bottom from scratch with all the functionality in it. This is kind of more like the DCT you just heard about. That's right. That's its own application. But if somebody's already written most of it, it's really, really lightweight to do more. So if you want to do that, please do. If you need help with that, please let us know. And I think that's it. Thanks.
Great, thank you so much, Jim. So our next speaker is Kasper Kowalik, who will be speaking about Wholetail as Dataverse's external tool. Kasper is a research scientist working at the National Center for Supercomputing Applications at University of Illinois, and is also a software architect behind the Wholetail project. His main research interest concerns how people, not only scientists, interact with data, i.e. visualize, analyze, publish, or track provenance of it. He tries to write open source software to make all of these interactions easier.
Hi, thank you for having me. Can you see my presentation?
Yes,
Yep,
looks
good.
good.
Awesome. So as mentioned, my name is Kasper Kowalik. I'm working at NCSA, and I'm a software architect for the Wholetail project. So just a few words about what Wholetail is. It's like we are a NSF DIBS project. So basically, we are tasked with creating software that can serve as a building block for other people creating research infrastructure. And we aim to create a web-based tool that's going to be a platform for creating reproducible research objects that we call tails. This is going to be a place where you can create them, where you can share them with other people, where you can publish them and get the DOIs for them to get credit for your work. I added a couple of links to the presentation where you can find more about that, and also how to enable Wholetail in Dataverse, like our link to the manifest.json that does that. So one additional word about what is a tail. So you may heard things, you may heard terms like capsule or a research compendium, and in our project we call those object tails. And it's a combination of code, some narrative, like you think about it as a living paper, or just basically a thing that you want to show about your research, a compute environment, like all the description of all the software that is necessary to run your particular code or execute your paper, and also to present it somehow, some sort of user interface, and of course the data. And the data part is the place where data repositories and specifically Dataverse come into our project. So what we offer is basically we allow people to express or reference the already published data through DOI or even through the Dataverse URL. That's also possible, and get that data and execute that in a live compute environment. So as Phil mentioned, we're integrating with Dataverse on a dataset level, although we also have a version of a tool for a previous version of Dataverse where it was only possible on the file level. But even in that case, even if you clicked explore on a single tabular file, we were still getting everything, the entire dataset. So once you go to your favorite Dataverse, and provided that the admin actually install the Wholetail as a tool, let's see what the Wholetail can do for you. So once you hit that explore button, you are transferred to our site. You're asked to log in, and after you log in, you're greeted with that particular model where you are immediately creating a research object, or you're immediately creating a tail. So that you already have the data because you're coming from the Dataverse, so that's going to be a part of your tail. What you can do is basically give it a name and choose a basic compute environment, like let's say Jupyter Notebook or RStudio, anything that you would like to use to interact with the data. There's so right now there are like 5 flagship environments that we use, but there's option to add more if users are interested. So once you select the environment, you can create and launch a new tail. And there are 2 things that are happening. So one, we are using the Dataverse API to actually get you the data. There are 2 options to do that. One, I think most people would start with that, is to actually download the data and put it in an environment that we'll be later on using. So whatever the data set contains is going to be copied over to your environment. But there's also an option to treat the data only as a reference and fetch it on demand. So whenever your script or your notebook actually touches some file from the particular dataset, only then the transfer of the data begins. And because we are coming into the Wholetail platform from the Dataverse, we know all about DOIs for individual files or entire dataset. We keep track of that relations that we keep track of that relations, and we can use it later on to store that information that our tail was created based on the DOI from the Dataverse, and that makes the metadata that allows basically to give credit to the either the authors of the dataset that you're using, or just the particular instance of Dataverse that you're using. Additional things worth noting is that, so that's one thing, this is the data. The second thing is the environment. So we are using repo to Docker. It's a tool basically that uses certain configuration file to create a on-the-fly Docker image, a Docker container that can have additional software installed. So if your Dataverse package contains a specific set of files, like, for example, requirements.txt, that can express dependencies in Python, or install.r that can express dependencies for RStudio or R in general, we will detect those, and the environment that you will get with the files from Dataverse will contain those packages, and they're going to be installed there. So after all that happens, like if you're if you're just using simple data set and there are no dependencies, that should be fairly quick. But if you are expressing more, if you have a lot of dependencies, they take some time to build, the whole process of import or creating a tail can take some time. So afterwards, you're greeted with, like, assuming that everything went fine and everything was successful, you're greeted with a chosen environment. So in this case, it was a Jupyter notebook. And as you can see from the screenshot here, unfortunately, it's not the live demo. You get all the files that were in the initial dataset that originated the call through the external tools mechanism to the Wholetail platform. So this is the thing, what basically the functionality that Wholetail gives to you right now. So you can take any dataset from any Dataverse and go to Wholetail and get it running, access those files in any environment of your choice. But what we are also doing, and what we would like to do in the future is actually store the research objects details themselves in the Dataverse. So hopefully, so I didn't have time to like expand that idea, but hopefully you can follow the link that I put here in the presentation and see how we do that for Zenodo. And in that case, the published research object contains all the references to the files that are already existing in the repository. So we're not copying files over and over and over. So it's just going to be expressed as a related identifiers, and we'll be able to recreate those environments and back and forth. So that would be like a full publishing circle, basically starting with that data set in the Dataverse, creating a tail out of it in Wholetail, and publishing the resulting tail back to the Dataverse. So that's one thing on our roadmap. The other one is curation workflows that were already mentioned. Like a lot of people are right now, a lot of journals are right now requiring that particular functionality. When the author is depositing something to Dataverse, then there's a whole process of going back and forth with the curator and the reviewers, and that may involve running, accessing that data in an interactive environment. Okay, thank you.
Great, thank you so much. So our next speaker is James Honecker, who will be speaking about 2 ravens for machine learning. James is a research associate in the Harvard Computer Science Department. His work is primarily on statistical software. He leads development of white noise and previously PSI, and is chief privacy engineer for OpenDP. He is an author on several statistical software packages, including Amelia for missing data, Z-Lake for statistical inference and interpretation, and 2 ravens for automated machine learning. Take it away, James.
Thank you very much. It's nice to be talking here. It was heartening to see our name turn up in the early history, almost the prehistory of Phil's early talk. This is a platform that was originally incubated at IQSS when I was able to work across the hall from Phil, and enjoyed those days very much. We've heard people talk about data previewers. If there's a way to couch this in those terms, that 2 ravens might be considered a model previewer, which is to say that as archivists and with Dataverse, we do a really great job democratizing data, making all of this open data available to the outside world. But it's one thing to give people data and say, look, it's free, it's open, you can do what you want with it. There aren't necessarily a lot of people who can then take that data and immediately see what it means to them. Often that involves them downloading the data and then leaving your repository and going off and doing something else in whatever toolkit or stack they know. And so every time you're successful, they leave the archive. There is, of course, and it's not everybody who can do that. So even if we're democratizing data, we're not necessarily democratizing science, right? So, it's very hard to find people who have all of these skills to find and rederive and the models that were implicit in this data when it was created. So we started off, again, incubated at IQSS. We got picked up by DARPA, and for the last 3 or 4 years have been heavily supported by them to come up with a way to try to democratize the science behind open data. That is, try to make it so that people without any data science training, without any programming ability, certainly, can understand what's going on in the data, can say, I've got data here. This is what I want to learn. Can you build me a model that tells me if this is true or not? Can you build me a model that predicts this thing I care about in the future? Okay, so what Two Ravens does is it allows people at all levels of expertise to explore a data set and try and describe what it is they understand about the data and what it is they're trying to learn. And then the data itself, the platform itself, will appropriately construct a model that allows you to see whether the things you think are true or whether the thing you're trying to work out can be predicted or not, okay? It's also, you know, for those more technically oriented here, it's a thin client, so it's running over the browser with, you know, cloud backend computation. It's broadly accessible, so it can work on a tablet, it can work across devices, it's device independent. That's an important way to like bring it, you know, to a wider use base and also bring it into the classroom. We think it's a good way to bring quantitative reasoning into the classroom because you don't have to spend all of your time being a statistician or playing with statistical code. Okay, so I'll talk about the things that are rolling out in phase one, where we're getting reasonably mature at this point, and this is what exists in the current system. One of the things it'll do is it'll say, oh, you have a data set? I've just found a bunch of models without you telling me anything that I think reveal interesting patterns in this data. Are any of these interesting to you? Would you like to pursue them? So problem discovery. Data exploration. So the original roots of Two Ravens when it was at IQSS was how can you learn the patterns inside the data? How can you get some quick visualizations without leaving the archive? So there's still a strength in exploring 1, 2, 3, 4-dimensional relationships. Manipulate the data. So if you need to extract not the entire data set, but just certain portions of it, or you want to make new variables out of old variables, and again, not leave the archive. That was very, very early Dataverse functionality to be able to construct new variables within Dataverse. It persists within Two Ravens. And then the strength here is I want to tell you a story. Can you build a machine learning model that matches that story? Okay, so I think all of these variables might be leading to war, and I certainly know the oil matters, and something like some geographers tell me geography really matters. And then when you've constructed a large number of models, how do you interpret them? How do you explain them to a naive user? How do you compare which models are predicting which features? Okay, and I don't have time to come into forthcoming things, but there's a number of ways that we're being funded to continue it, to adapt this for time series and for merging new data sets and making joins and for dealing with metadata. Okay, so there's a large number of project instances that are available and various code that you can look at. What I'd like to jump to in my last minute is I think I have a demo, although I know that sometimes demos don't work so well on Zoom, so let's give it a shot, okay? Are people able to see this? So here we are, we launch into the system. Immediately, what it's telling us first is, the first thing I'm gonna do is start solving models automatically. Okay, so this was a live demo, so in the minute while I'm doing other things, it's also
James, your audio is breaking up.
Oh, I'm so sorry about that. Okay, probably we're overloading this up on our site. But here we get, so it's suggested models. We built a model based on our own expertise. Here, this is a long list of models that is automatically constructed on the data sets. And it's comparing which ones have different meaning, highlight different variables as being the best predictor. And then in this, some visualizations of what the relationships are that are being discovered by these machine learning models. So I'd encourage you to go take a look at those demos. I will stop screen sharing and thank you for your time. And so I hope you got most of that audio. Thank you.
Thanks, James. That's always the danger of the live demo.
Well, yeah.
Okay, so our next speaker is Camille Gurin, who will be speaking about a set of new Dataverse external tools for advanced data visualization in hard sciences. Camille is a system administrator at WAN Computer Center of Białystok University of Technology, the operator of Nmadm Research Network. For over 10 years, he has been involved in development and deployment of several IT projects in cooperation with Polish Optical Internet, the consortium of academic computer network and high-performance computer centers in Poland. He's an IT technical architect of biodiversity portal at openforestdata.pl, which is being built together with Mammal Research Institute and Institute of Forest Sciences on top of the Dataverse as a system core.
Thank you, Caitlin, for introducing me. I will be speaking about a set of our new Dataverse external tools for advanced data visualization in hard sciences. And my presentation will be shorter than usual because I have a plan to show a live demo of the external tools at the end of my presentation. So the first external tool is a 3D viewer. It's using the 3dviewer.net library, and as you can see, it will show a 3D object directly in a web browser. Later, I will show you how it works in the web browser. The second external tool is Dcom Viewer, and it's the same. Yes, it's capable of showing the Dcom images directly in the web browser, and it's using the PACS solution, the Hortense server, and the Osimis viewer. Yes. So the third external tool is a chart viewer, and as you can see, it's an integration with the Grafana. Yes. So that's why you can see this fancy chart in the screen. The fourth external tool is a map viewer. It's a simple integration with the GeoNode, and as you can see, you can navigate through the map directly in the Dataverse. And the fifth external tool is a TIFF viewer with the tiled pyramidal format, and it's very useful, for example, for a gigantic file size of TIFF files, for example, done with the scanning microscope. Yes, so it's very useful in hard sciences. Okay, so external tools gives a very attractive and crucial functionality to the end users, especially for hard science portals, because it's very fancy to show the data directly in the web browser. And we would like to thank very much to Harvard, Jimmy, Phil, Slava, and Gustavo, and all of the community that provide to us the Dataverse, because without Dataverse we couldn't build such a portal. Yes, so thank you very much for giving that software. And we've got also another ideas of external tools. There is also an idea to build a viewer that will be dependent on the raw graphs EO, and this is very handy library to generate the charts or diagrams, specialized diagrams. And there is two ways to integrate it. One way is to give to the user to the end user a possibility to himself choosing the appropriate diagram. Yes, and the second way is to generate the diagram automatically based on the format of the data. And the second idea is to integrate the PileUp.js library. That is a very good library to show a visualization of genomic data. Okay, so I will show you how those 5 external tools works in the live. Do you see the screen? No,
I think you might have to stop sharing and share your browser window instead.
Okay, wait a moment. And now?
Yes.
Okay, so I will show you the example of 3D object viewer. I'm on Wi-Fi, so I need to wait some time. Okay, so that's a 3D viewer. You can rotate the object and so yes, and so on. Another external tool is a chart viewer. It's from the Grafana, yes, and you can for example zoom to the some time, yes. And what is very good in that solution that the Grafana is using the InfluxDB underneath, and as you can know, the InfluxDB is very good tool to store billions of points in time, and is very scalable. Yes. Another tool is a computer tomography image, a Dcom Viewer, and as you can see, it's capable. Oh, okay, it's working. And here in this viewer, it's based on the Osiris viewer from the Hortense server, and you can do everything. Yes, here you can show the image, you can change invert the color, you can zoom to the object, you can rotate the object, yes, left, right, flip, horizontally, vertically. You can measure the length, you can measure the angle, yes, put some pixel probe, put some annotation. Here is an elliptic ray. You can also put some innotation here, for example, notation. Okay, and you can print this image, yes. So that's the functionality of the Dcom Viewer. And the fourth external tool is integration with the Grafana, and as you can see, you can navigate through this map, yes. And the last one is the tiled pyramidal viewer, and as you can see, I can zoom in, deeply zoom into this object. Yes, it's very useful for example, for the scanning microscopes, because the TIFF files from the scanning microscopes are very huge. The size of these files are a few gigabytes, so it's very useful to do that in this way and to provide this data to the end user. Yes, and that's all. I will switch to the last slide. Wait a moment. The last slide, share. Okay. Presentation. Okay, so thank you for your attention, and if you have any question, just ask me. Do you hear me?
Yes, that was great. Thank you.
Oh, okay.
We're all shocked.
It's not a rocket science, believe me.
Okay, so I think we're switching over to me doing the introductions for a while. So next up, I'd like to introduce Shenye Yi is an associate professor of computing from the New Jersey Institute of Technology, where he directs the Urban Informatics and Spatial Computing Lab. His expertise is on the heterogeneous nature of knowledge graph involving various organizations, people, and resources. He builds AI and open ontology architecture strategies upon network science approaches, with projects funded by the National Science Foundation, the National Institute of Justice, Department of Commerce, and Department of Energy. So, Shenye, you could take it away.
Thank you. Thank you, everyone. And thanks for the introduction. And I'm also happy to announce I will be relocated to Texas A&M University starting from this August. So this might be my last time to present as a New Jersey Institute of Technology professor. Okay, let me share my screen. Actually, I provide, let's see, how can I share my, okay, well, I can share my video. Okay, share screen.
Are you a host?
Yeah.
Let's.
Yeah, okay, so can you see my screen?
Yes.
Okay, so I hope the sound can work because I pre-recorded a kind of some minutes video to show how we utilize Dataverse API and put into our highly interactive smart data finder kind of a toolbox.
Welcome to the introduction video for Smart Data.
Can you hear the sound?
Yes.
Okay, wonderful, wonderful.
Finder tool. We aim to build a knowledge discovery tool. All the data in the demo is provided by the Dataverse API. And we build a workflow to import data to the graph database. Here we use Neo4j and use default visualization to present sample data. Different colors here means different kinds of information. For example, blue is keywords, orange is the raw dataset. We build our own search interface in front of that. First thing is, enter a search term in the autocomplete text entry. It will autocomplete the query. Here we choose crime and show relevant results. Check the help box to read the help text. Each node represents a keyword appearing in the result datasets. Terms frequently occurring in the same datasets are linked and placed close to each other. Big nodes means terms appearing in more result datasets. Green means terms appear more frequently in the result datasets than in other datasets. Use mouse wheel to zoom in or zoom out. Drag and drop in an empty space to pan the graph. Drag the right bottom corner to enlarge the canvas. Check the lens box and drag and drop to activate the lens. Read the labels of selected nodes from the tag cloud. Move the lens around to learn more keywords. So the relationship between different datasets will present to use clearly. We hope researchers can be inspired by such datasets relationship exploration. Right-click a tag to add it as a filter term. Click the term to remove it from filter terms. Add a new filter term. Add one more filter term. Use the lens to examine the keywords in the filtered datasets. Add one more filter term. Browse the datasets. Click a link to open the dataset in its repository webpage. We are adding more features to this tool. This scatter plot shows temporal information, also allows users to interact with datasets based on time. Thank you for watching this video.
Okay, so that's we put together. So in other words, we have already fully access Dataverse API. There's a lots of other work we can done. We can make it interactively visualized. We can build more indicator to that. And we also plan to utilize it when after I arrive at Texas A&M, because I will promote the across campus computational social science and urban data science there. For that is Dataverse rich collections of all these wonderful data can be fully and widely utilized by students and other researchers. If you have any questions, please let me know. Thank you.
Great, thank you so much. Again, we'll be holding questions till the end. So next up, I'd like to introduce Masa Naziri is a data science lead at the biopharmaceutical department in AstraZeneca. She currently leads the AI-driven manufacturing initiative at her department. Masa has been involved in building fair data management solutions for AstraZeneca and has introduced Dataverse to the company. To facilitate data deposit to Dataverse, Masa and her team have worked on an integration tool to move data between Dataverse and a statistical software called JUMP. Please take it away, Masa.
Sure. Thank you very much for the introduction, Phil. Can you hear me well?
I can hear you. I can see your screen, your slides.
Great. Yeah. So as Phil introduced, this presentation is about the integration between JUMP, which is a statistical analysis tool being widely used by the scientists in the biopharmaceutical department in AstraZeneca, and Dataverse. But before talking about the tool, I would like to take 2 minutes to very briefly explain how Dataverse is being used in AstraZeneca. So AstraZeneca is a biopharmaceutical company, and within the biopharmaceutical department, we generate a lot of data through the experiments that the scientists do in the lab. So the lab data is then being collected into the data repositories, instrument data repositories, and the scientists would fetch the data and aggregate the data that's coming from different instruments, for instance, and build this aggregated data set. And with some pre-processing, then they would send the data to the data analysis tools, and they use a variety of tools, but JUMP is one of the softwares that's being used widely by our scientists. So once that data is analyzed, then the results of these analysis in the form of charts or tables or statistical analysis numbers are being produced, the contents for reports that we're generating. So these reports are we refer to them as process development reports, which are extremely important because eventually the content of these reports become part of the biological license applications that we submit to FDA for drug approval. So these development reports have to also get verified, means that the contents, the data that's appearing in the reports, as well as the type of the analysis and analysis the script need to be captured and need to be saved so that the data is the analysis and the data is traceable. And the previous approach that we had for capturing all this data and the analysis was that the data was everywhere in OneDrive, SharePoint sites, Box, scientist computer. And we introduced a centralized dataset repository with a Dataverse installation that would make this data fair, make the data and also the analysis results and scripts for those findable, accessible, reproducible, and interoperable. And this is very highly important for us. So to encourage the scientists to bring the data into the repository, we definitely need to do some work because there are two different approaches that we're taking here to try to make this biopharma data fair. And one approach is that we're developing some tools well, we call them the automated data analysis tools. These are normally in the form of R Shiny applications or Python applications. And the way the scientists would then bring the data to these applications, and we would do the analysis through the applications. But as part of additions that we have in those applications is that we try to collect the metadata from the scientists and push the data into, create a data set and push the data into Dataverse through R and Python applications that we have. But a second approach is through the integrations between Dataverse and the data sources and the tools that the scientists widely use. And one of these tools, as I mentioned, is called JUMP. So it is a data analysis and visualization tool, and most of the BPD scientists use these tools for their DOEs, the univariate or multivariate studies of their data and their experiments. And the integration between Dataverse and JUMP, this would definitely facilitate more efficient archival of the data and also the analysis and the results for the reports that are being generated. So the JUMP version that's required, of course, for this integration is version 14, and that's because from JUMP version 14, the add-ons are enabled in JUMP, and most of the interaction with Dataverse is done through the HTTP requests and APIs. So just a few slides to show what this add-in look like. So the scientists would be able to get the add-in and very quickly install it in JUMP. And then under the add-ins, they would see the JUMP Dataverse section, which then allow them to read the file or upload the file, read the file from a data set in Dataverse, or upload the files and their data and analysis result into a data set again in Dataverse. For now, this is only at the data set level, but we're expanding this in future. So a quick workflow would be, assuming that the data is currently in Dataverse, then the scientists would have to provide the dataset ID for now and their API keys. And then we list the files that are currently in that dataset, and then the scientists would get to select which files they would like to work with. These would be mostly here, either the JUMP files or the tabular, any type of tabular files. And once that file is loaded from the dataset, Dataverse dataset into JUMP, then the scientists would then, they could do a wide range of different type of analysis. As you could see, they could do DOEs and do many other type of analysis that JUMP allows them to do. And once the analysis is completed, then they could save the results and then deposit the data back into Dataverse. So for depositing the data back into Dataverse, there are two different options here. JUMP creates this object, which is called an open data table. And that has the scripts, that the analysis script, as well as the data combined in one file. And that's a JUMP file normally. So the scientists either get to push that JUMP file into the dataset. Again, they have to provide the specifications for the file that they're uploading, the tags, or also the dataset ID and their API keys for now. Or they get to upload only maybe the tabular files or only the scripts if they wish to. So that would be the second option they have for uploading the data. And so if the upload is successful, then the files appear with the tags and every descriptions provided here into Dataverse. So as you could see, this tool was mainly, this add-in or integration was mainly created to facilitate data deposit and retrieval between JUMP and Dataverse. And the main reason for that was to encourage the scientists to push the data and archive their data and to promote data sharing. And we have scripts that we definitely provide to the Dataverse GitHub project, and we'll be happy to do that. And also we are working on improving this to allow dataset selection through the JUMP interface, so the scientists would be able to select the databases that they have access to and select the data sets that they have access to within those databases to be able to pull the data in or push the data without having the need to provide a dataset ID. And the other part that we're currently working on is that we would like to enable the scientists to also create a data set through the JUMP interface. And that is the end of my presentation. Thank you.
Wow, that was fantastic. Thank you so much, Masa.
Sure.
Next up, Matthew Dunlap is a software developer for the Odom Institute at the University of North Carolina, Chapel Hill. Before working at UNC, he was a developer for Dataverse with IQSS, and we shared an office for 2-3 years. So yeah, please take it away, Matt.
Hi, let's see here. Let me see if I can screen share for the first time ever. Okay, share the PowerPoint. Oh, that's not quite what I meant to do. We'll do it like that anyways. Okay, so here's my presentation on confirmable reproducible research, curate,
data curation workflows utilizing containerization. And as Phil said, I am a developer for the Odom Institute. Okay, there we go. So there are some problems with science data. Publication data and code is usually not verified before it is published, and the current workflows for curation and verification require many manual steps. The different groups, the authors and the curators, are emailing back and forth. The code is like run in different environments, and when the stuff is submitted, it may not run for the curator. So the solution is curate. It's an open source web-based data curation environment. It supports complex data curation and verification workflows. For the current development, which is work in progress, we're targeting one workflow, but as we move forward, we will target more. We're managing and hosting containerized notebooks so scientists and curators can work in the same environments, or at least during the start of the curation process, use the same environments to go back and forth. Then at the end, the data is deposited and the notebook info is deposited in Dataverse. We use Binder and repo to Binder, Binder Hub, and GitLab to run Jupyter notebooks. So I want to take most of this time to walk you guys through a data curation workflow, because I think that's really useful to explore why these sort of tools are useful. It's admittedly somewhat complex, but I'll walk through step by step. So at the beginning, the editor of a publication creates a new manuscript. For us, a manuscript is the root object in curate. It stores the metadata, any notes. It's like the overarching object for the publication data and code. They then invite or add an author to curate. The authors, if they need to, they create an account, and then they create a manuscript submission. The submission stores that round of the code and data along with any additional metadata relevant to that specific round. When they submit this, it gets passed off to a curator. The curator reviews the submission to make sure that the data and code is there, the metadata lines up. They may do an initial run of the code. And if there are any issues, which there almost always are, the issue is submitted to the editor, who then reviews it, and if needed, passes that back on to the author. When there aren't any issues, a verifier then gets the code and data. The verifiers are more domain knowledgeable to the specific fields and are tasked with running the code. They're usually like postdocs and graduate students at various universities. If there are issues there, that also gets passed back to the editor, who communicates it to the author. Once the issues are resolved and everything runs in the container, the manuscript is finalized and a draft version of the data set is put up in Dataverse, waiting for the editor to publish the article. At that point, the code gets published, the code and data gets published as well. So if you want more info on a data curation workflow, I recommend looking, these slides will be up later. This is a good place to look at details on a curation workflow. So our tool is very much a work in progress. And it works end to end now, but we need to do a lot more. I wanted to give a very simple, or give a screenshot of like the landing page for the tool that we're working on, showing how the different groups will explore the manuscripts and the submissions and do the various actions, including launching the Jupyter notebooks. So our current goal is to get the current workflow and Binder Hub integration ready for production and use at UNC. Once we do that, we want to expand to support many more workflows and allow it to be as customizable as possible for different groups, like folks here. We also want to support deeper integration with Dataverse, such as badging, the ability to launch from Dataverse into curate directly, etc. I have a GitHub repo if you want to follow along with the development process. Anyways, thanks a lot. Thanks to the Alfred Sloan Foundation and to everyone on my team. I couldn't have done this without them. Thank you.
Thanks, Matthew. And now it's time for our final speaker. Tomasz Miksa is a senior researcher at the TU Wien, Austria. He chairs the DMP Common Standards Working Group at the Research Data Alliance that works to realize machine actionable data management plans and coordinates their deployment at major Austrian universities within the Fair Data Austria project. Please take it away, Tomasz.
Thank you very much for the introduction and the invitation to the workshop. Today I want to tell you how we try to minimize the amount of work for the researchers by using machine actionable data management plans, in short MADMPs, and Dataverse. To begin with, maybe quick explanation what data management plans are. Most of you can know it from the requirements of the funders. For example, in the US, National Science Foundation wants you to write an outline of what kind of data you want to produce during your research project. The same situation is in Europe. This is usually a lot of writing, a lot of PDFs, a lot of bureaucracy. Researchers are usually not so happy about writing the documents. And what we've been doing recently at Research Data Alliance is trying to find out what parts of data management plans can be made machine actionable. So basically, which parts can be interpreted by machines, and what can we, how can we break down DMPs into a set of categories, a set of values that the computers can read, and then actually trigger some automated decisions. We've been working on this topic for the last 3 years. We had a group at the Research Data Alliance with almost 200 members. Most of the major DMP tool providers from all around the world were with us, and we produced a recommendation which describes this universal standard for expressing any type of DMP. So it can be, it's independent from the template, it can be used for Horizon Europe or for the National Science Foundation or any other. And the way I'm here, the reason why I'm here and I'm talking to you about it is that there are some benefits for the researchers, but also for the repository operators, so people like you who are running Dataverse instances. There is information in data management plan that can be reused. So for example, the researcher describes that he or she is going to deposit data into Dataverse and is going to use this kind of license and is going to set an embargo period. And all this information can go automatically from a DMP into a Dataverse repository. On the other hand, when the data is deposited into the Dataverse, the information on the DOIs or any other metadata can go back to the DMP, and this can be later submitted to the funder, because the funders actually want to see where the data was deposited and whether the agreement, the funding agreement, which was foreseeing that data will be made available, has been actually fulfilled. And to demonstrate how this can be done, how can MADMPs exchange information with Dataverse, we had a group of students at the Technical University in Vienna who developed such an integration. And I have here now 2 use cases I would like to show you quickly. So the first use case is about using the information from machine actionable DMP to fill out fields in Dataverse. So basically we want to reduce the manual input from the researchers. And this is usually happening at the beginning of a project when we're talking about things that are going to happen in the future. The second use case will be about situation that you already did your research and you want to export data into an MADMP to, for example, show it to the funder. So let's start with the first use case. The first use case, what you do in the beginning, you just start by creating manually a placeholder data set, something dummy, it will be deleted later, but we have to create it to fulfill the requirements of Dataverse workflows. And then you upload a data management plan to Dataverse and publish it. And as you know, publishing triggers the hook that can send a message to the external service. And this external service takes the data management plan and based on its contents, create data sets in Dataverse. So in our data management plan, which was describing correlation between number of marriages in Austria and students of public universities in Austria, which has absolutely no sense, but it was just a fake example. it has 4 data sets. So there will be produced data, some source code, and some statistical data. If you click at the individual data set, you will see that some of the metadata fields are already filled out. So for example, the description, something about the sensitive data or personal data. Of course, there is still no file. The user has to upload the file when it will be created, but it's already less work for them. And the second use case comes with the Explore button. So the data already exists in the Dataverse because the researcher already did the research, and now they want to reuse this information in a DMP. So they simply click the Explore button, and then a snippet of code is generated that can be sent to the DMP service. So this is it basically from me for today. If you would like to learn more about the Dataverse integration, please use the first link where everything is described in detail, including the diagrams, how the software was designed. If you want to read about the standard for MADMPs, check out the second link. And if you're interested in any other case in which you can use information from MADMPs, please check out our hackathon website, where we have been working last week on, like 2 weeks ago, on several different use cases. And let us know if you want to continue this work, if you want to run it on your own premises, and I'm happy to answer any questions you may have. Thank you very much.
Thank you, Tomasz, and thank you to all the speakers, all 9 of you. Let's see, how much time do we have left? About 15 minutes. So I think it'd be best if people are able to just use their voice to ask their question. You can, of course, type it in the chat if you want. But as we said at the beginning, we were going to try using this raise hand thing, and it'll just preserve the order of who raised their hand first. And actually, Mercedes has a raised hand. I don't know if that was answered already, Mercedes, from earlier. But did you still have a question or comment? Or maybe she stepped away.
Hi. No, I'm here very much. Very interesting session. That was a long ago. Let me remember what it was for about the Data Explorer. So it was at the beginning. About it that yesterday in the metadata session, the Steve Macker from ADA presented the changes for DDI, CDI that will make changes into the variable metadata eventually. So I just was wondering if that group for the Data Explorer, if they've been reviewing or if you're actively looking into how would that affect that tool so that well, we can take advantage of the improvements of the DDI variable metadata with this new version.
Yeah, no, we haven't been in touch with them, but thank you for the heads up. We'll definitely try to connect with them and see what kind of implications that will have for the data curation tool. I know that there are some ways, we can continue to improve the usage of DDI in the tool. So it sounds like, that will be another step towards that as well.
So a question came in for Tomasz from Philip from Norway. He's asking about DMP tools. How many DMP tools are implementing your recommendations, or rather which ones? So I guess he's asking which DMP tools are implementing your recommendations.
I was just typing the answer. So in the hackathon 2 weeks ago, we had people from the DMP tool, DMP Online, Data Stewardship Wizard, RDMO, Argos. I know also about colleagues from Norway, and so this one's for sure. We have a list of participants on the website. I will just paste a link in the chat if you want to see exactly who is on that.
Great, thank you. And I see another question from the notes. I think I can just handle this, where it says, can we have all the external tools registered in our Dataverse? Wondering about overloading or stressing the Dataverse software. So the answer is yes, stick them all in there, because all that's happening is that a row in a database table in Postgres for Dataverse is being populated by it's basically like the formula to construct the URL. So it's super lightweight on the Dataverse side. A lot of the heavy lifting is being done inside those tools themselves, which are on different servers, not your own Dataverse installation.
So Phil, we have another question in the notes. So the question is, how sustainable are the external tools, such as Wholetail, et cetera, and the updating of the tools in relation to Dataverse releases?
I mean, the tools range in complexity, where, like Jim was saying, and actually I wrote down this quote from Slava, which is actually Jim talking, "A few minutes work that makes you look good." Those file previewers are, like Jim said, wrappers around some JavaScript, and they're fairly lightweight. So those feel pretty sustainable to me. But then, you know, bigger tools like Wholetail is like, it's a whole world. I mean, I would say Wholetail is similar to Dataverse in complexity. It's some code, and it takes work to deploy it yourself. So I guess you would just be evaluating, just like you do with any software. Is this software the horse to bet on? Is this the one that's going to be around for 10 years, 20 years? And so I think we just use your normal skills in trying to decide that stuff. Oh, do you want to jump in?
Yeah, I would like to jump in since Wholetail was mentioned twice. So maybe like exploring the worst case scenario, like the Wholetail disappears after the funding's end. There's one thing worth noting is that most of the work related to Dataverse was also ported to other open source projects. Like we are ourselves open source project, and like anyone can fork and carry on the torch. But we also ported all the things that we did for Dataverse in Wholetail to repo to Docker and Binder, which are much bigger project, much more widely used. So at least that part won't die that easily, I guess.
Yeah, and I had a note to, since you're here, Casper, I want to thank you again. I know that I got a shout out by Tim Head from the Binder project, said Phil Durbin and friends. And like, yeah, the main friend here is Casper, who did all the heavy lifting, that did all the work inside that repo to Docker repo to get Dataverse support. So that powers both Wholetail and Binder. And I just heard curate also using repo to Docker. So thanks again for that, Casper.
So I'm not seeing any more questions in the notes. Are there any others in the chat that we haven't answered yet? I think people have been pretty good about replying so far. So in the notes as well, Phil, there are some sections on would like to have things. I don't know if you wanted to talk about those now or just, you know, let people kind of continue to plug away at things in there.
Well, if you don't mind reading them, I don't have the notes up, but I will bring them up.
Sure. So there's quite a lot of things here. So things you would like to have: ability to register tool for multiple MIME types at once versus separate registrations. Ability to limit what a tool can change versus giving them the full yet still limited power of the use of the API key, or of the user via API key. Ability to add preview tool without connection to explore button, and then there's a reference to what I assume is an issue. All the new previewers and more. And one that I put in was a plugin / external tools gallery, kind of similar to what OJS has, for those that are familiar with it, that allows for the direct install of some external tools, which have been approved by the Dataverse team. And I know that would be a large development undertaking, of course. And then somebody had put underneath that, would it still be an admin level capability, or is there interest in per sub Dataverse selections? My thinking on that is that, you know, you might want that to be configurable because you might not want people installing tools on your Dataverse instance, but.
Right. Sure. This is a lot at once. 5 bullets.
It's a whirlwind. It's a whirlwind of stuff.
But yeah, I can try to comment on some of these. So yeah, the first one was a no-brainer about multiple MIME types, because what happens now is that we have a nice image previewer, but you have to load separately a tool for PNGs and a tool for GIFs. And it would make more sense to add a feature of the external tool framework that you could just specify multiple MIME types and say, I only want one row in that external tool table in my Dataverse installation, and the same tool just gets reused for multiple MIME types. So yeah, I don't know. I feel like Jim brought this up, I don't know, well over a year ago, and I don't know if there's an open issue for it or not, but it certainly does make sense. Limiting what tool can change, this conversation goes way back to Dataverse 4, where we're like, we need some kind of API token, API key to, so people can authenticate. And we're like, well, we'll just do the thing that's the kind of minimum viable product is like, just give them the key that means this is you. But it means you can do everything that you can do. So like if you have a data set that's in draft, never been published, you could just delete that data set, and that could be done accidentally by a tool, perhaps. So that's a little bit more on the API. It's like a feature of the Dataverse API to have like limited access tokens, that this can only be used for reading, like say you want to download a restricted file, something like that. Yes, that would be a good addition to the whole API framework. I don't know, Mike Hepler, I don't know if you're around, but if you want to talk about this one, because it links to the issue you opened. In the notes, it says, the ability to add a preview tool without connection to Explore button. I guess the idea is that if the whole experience is right in that preview pane, then why do you need to like click a button and have it go into a new browser tab? So Mike, are you around for comment?
This stirred up a little bit of controversy. I don't want to change the intended functionality of any installation, especially the installations that created these previewers. But I guess what I'm proposing is that in order to maintain their current functionality, if we create what I'm proposing, if we go with what I'm proposing, if you wanted a previewer tool to link to both the preview button, which doesn't exist in the UI right now, as well as the Explore button, then there would be the ability to set that same tool up under both configurations. But right now, there is no ability to add a preview tool that does not add an Explore button. And basically, the Explore button becomes a duplication of currently the way that it's currently configured in the application. The Explore button becomes a duplication of the open a new window tool, the button. I believe it's still branded as Explore on, but basically this becomes an issue when you have files such as tabular files that are linked to Explore tools such as Data Explorer or Two Ravens or World Map, where you can go to these tools and actually do exploring, which implies more than just looking at, previewing. So I wanted to create a separation between what a preview is and what an Explorer is, because for some file types, there should be that separation, because to be honest, I'm disappointed when I click an Explore button and I get the exact same functionality that's given to me in the Explore, I'm sorry, the preview tab on the file page. So there's just that personal preference. I realize I am not an installation. I am just one developer, but as somebody who is user experience focused constantly, it was confusing to me, and I had a different expectation when I clicked that button. And we probably should, before we go and change anything, do more outreach to the community, do more user testing, get some sort of consensus between those two groups, and make our decision based on that, and not just one rogue developer's personal preference.
Cool, thank you. And I think you brought us to the end. So it's time to say goodbye, but we want to keep the conversation going. So keep typing in the notes doc for sure. We'll see you in the Google group. It's called Dataverse Community. Twitter, there's chat.dataverse.org, support@dataverse.org if you want to email, make a support ticket. And I don't know, Caitlin, any last words?
No, just thanks everyone for presenting today and giving us your time. And this is a great session. There's so much in the notes. Please continue adding your ideas and comments.
Thank you so much. And again, thank you very much to the speakers. Have a good day.
Thanks, everyone.
Thank you. Bye.
Thank you.